by day weather forecasts. Okay, like what temperature is today, what temperature is going to be tomorrow, and what temperature is going to be at different hours of the day. That is basically provided by this minimum maximum thermometer. Okay, so that question might also be asked. Okay, now moving on, we also talked about a conversion of scales, conversion of temperature from one scale to another. Okay, so first, Santosh, you tell me, how do we convert temperature from Fahrenheit scale to Celsius scale? There were two formulas now. Basically, there
Yes.
were three formulas. Okay, two
Yeah.
was related to conversion of Fahrenheit to Celsius, and then Celsius to Fahrenheit, and then another was related to conversion
Kelvin to
from Celsius, exactly, Kelvin to Celsius or Celsius to Kelvin. Okay, so first tell me, how do you convert a Fahrenheit temperature into Celsius?
C is equal to 5 by 9 F minus 32.
C equals to 5 by 9 into F
F
minus 32.
minus 32.
Very good. Okay, now Vaiga, you tell me the another formula. How do we convert a temperature from Celsius to Fahrenheit?
So Fahrenheit is equal to 9 by 5 C plus 32.
Yeah, into C plus 32. Very good.
32.
Okay, and how do we convert a Celsius scale in temperature from Celsius scale to Kelvin?
T is equal to K minus 273.
K
So
minus
K is equal to
270.
C.
Yeah, move on.
So C is equal to K.
K is equal to C. Okay. C plus 273.
C plus 273. Very good.
273.
Yes,
Very
sir.
good, guys. Okay, so now today we will be beginning with the new concept in regard to heat, that is how heat flows from one object to another. Okay, before that I have got three MCQ questions here. Okay, so we will try to quickly cover these questions and then move ahead. So the first question says that the temperature of water in a beaker is 40 degrees Celsius. What is its value in Fahrenheit scale? Okay, so quickly solve it. Okay, what is the answer? Anyone who got the answer? Yes, Sundu Sanvaiga. Anyone of you who got the answer?
And I'm getting.
Okay. Vaiga, what about you? Have you got the answer?
Yes, I'm getting
I
it. I'm
got
doing it.
the
Okay.
first answer.
Option number one.
Yes.
No, that is wrong. Vaiga, what about you?
No, I mean
Option,
I got
so
the
option number
answer.
3.
I got the
Op
first answer,
okay,
not
you
the
got
first
the first
option.
answer. Okay. So what is the answer? What is your answer?
So the option number 2.
Option number two. Good. Vaiga?
So 1 minute. I
Okay,
got
okay.
3, so let me do it one more time.
Okay. By the way, option number two is correct here. Okay. So I'm solving it natural solutions. Okay.
Okay,
So
sir.
this
Okay, sir. I will do
40 is going to
option
getting
number
cancelled.
2.
Option number 2. Very good. So it's simply 72 plus 32. That is 104 degree Fahrenheit. Very good, guys. Now see next question. In this one, you have to convert the normal human body's temperature into Celsius scale. Although we already know the answer, but still we are going to solve this. Right, that is a formula required to solve the question. And after the class, no, you guys send me your exam syllabus. Okay,
Okay, sir.
your half-yearly exam syllabus, send that to me.
Questions, right?
Syllabus basically which chapters are going to be coming in your exam.
Okay. Okay, sir.
Okay, and
Portions.
science. Yeah,
Actually, I don't understand.
I was basically asking for your half-yearly exam syllabus, which chapters are going to come. By the way, Sundos, you haven't got admission in this school yet, no?
Yeah. No, I got.
You got, no? Okay, okay.
Yes.
So you are okay. So both of you are required to send your syllabus after the class.
But which syllabus?
Science syllabus, science for half-yearly exams.
I didn't got any syllabus.
You haven't got any syllabus. Okay,
Yeah.
okay, okay. No issue. Whenever you get your syllabus, do send me that. All right, or do update with me with that in the class. Okay, and do tell me what is the answer, guys, of question number 2. Here it's
I
given
was
in
sorry.
decimal. Okay, so we can solve it still. Okay, so it's 98.6 minus 32. So 5 upon 9 minus 98.6 minus 32. That is how much, guys? 66.6, right? So this decimal, we can remove this decimal and 10 will come in the denominator, right? So to cancel this, okay, it's 333. So 333 divided by 9. So that is how much? We can still simplify it further. So 111 upon 3. So that is approximately 37 degrees Celsius, right?
Yes, sir.
Okay, so that is the answer. Okay, now see the next question. Normal human body temperature is 98.6 degree Fahrenheit. What is the temperature going to be in scale? Now here it's in Fahrenheit. Okay, and we are required to convert it into Kelvin. So what we are going to do first in this question, guys? We have to first convert this temperature from Fahrenheit scale to Celsius scale. And then whatever the temperature comes in Celsius scale, you guys are required to add 273 to it. Okay, then you will get your temperature in Kelvin. Got it?
Okay, sir.
Okay, so we definitely know that in Celsius, the temperature is going to be how much? Guys, the temperature, if you convert 98.6 degree Fahrenheit in Celsius.
37.
47. Guys, what are you saying? We just solved a question
37.
on this 37. Okay, okay, good. I heard 47. So
No, sir.
37 degrees
37.
Celsius plus 273. Yeah. Okay, so you add it and do tell me what is the answer. Actually, there's only 3 options here. There's one more option going to be in this one. Okay, so I'm writing that 310 Kelvin.
Sir,
Okay.
That one
310.
is
310,
10
sir.
only.
Yeah, 310, guys. Okay, very good, guys. Okay, now let's move on to the concept which we are going to discuss today. Okay. Okay, still I have got few more questions. Let's quickly see that and then move on to the concept. So the correct method of reading a clinical thermometer is, read the options. Should we hold the thermometer by bulb before using the mercury level? Before use, the mercury level should be below 39 degrees Celsius. Don't hold the thermometer by bulb, or none of these. What is the correct method?
I think none of these.
No, one of the answer here is correct here. Read the question once more.
Yeah. See.
C. And Vaiga, what
Sir,
about you?
C, sir. C, don't
Exactly.
hold the thermometer by the bulb.
Exactly, because we are required to take the body temperature, not the temperature of our, particularly our hand. Okay. Which of the following thermometer contains mercury?
Both A and B.
Exactly. Okay.
Both A and B, sir.
Exactly. SI unit of temperature?
None of these, I think so.
No.
No, yes, Kelvin.
Kelvin. Yes, Vaiga. It's Kelvin.
Kelvin, sir.
Okay. Now let's talk about how transfer of heat takes place from one medium to another, or from one object to another. Okay. So you will see basically that energy will now always flow from a place where there's a high temperature to a place where there is low temperature, right? So if you are
Yes, sir.
sitting in a room, okay, and let's say you are sitting in the corner of the room, right? You are sitting in the corner of the room, and there's a fire burning in another corner of the room. There's a fire burning in another corner. So eventually you will also start feeling hot. Okay, you will also feel the warmth. Why is it so? Because heat from this region has traveled towards your region, towards you, right? So here in this region, the temperature was high. The temperature was high, and in this region earlier the temperature was low. So the flow of heat is basically taking from where to where? From a region having high temperature to a region having lower temperature. Okay, and eventually you will see after a few minutes, after some time, all parts of this room will have same temperature. So the flow will continue until all the parts of the room have same temperature, right? So earlier, this part where the fire was burning, the temperature was high, and in this part, the temperature was low. So let's say after 10 minutes, the heat will start to spread in every region of this room, right? So now every region has equal temperature, guys. Okay. So when
Okay,
every
sir.
region of the room has equal temperature, now the flow of heat will stop, right? So the flow takes place until all the region has acquired similar temperature, same temperature, right, guys? So this is simply not transfer of heat. So two fundamental things about it is that it is the flow of energy from a region of higher temperature to a region of lower temperature. Till when it will continue? Till when both the till when both the regions have acquired the same temperature. And talking about the ways in which this flow can take place, it will differ upon different mediums, basically, right? So let's say take example of this room. In the case of this room, the medium in which the flow of heat is taking, it is air now. That is air. Okay. Okay. What about if you are holding an hot object? Let's say this is a hot rod. This is a hot rod, and from one side we have lighted it using a candle. Okay. So in this place, the flow of heat from this region is taking place to another end of this hot rod, but the medium here is in solid now, right? So the heat flow in solid will take differently as compared to air. All right. And also if you were to heat water, if you are heating water, right, guys? If you are heating water, so in that case also you will see bubbles appear, and there's rigorous motion of water molecules. You guys can see when the temperature reaches close to 100 degrees Celsius, the water starts to boil. So in this method also, heat from the bottom of this pan reach the top water molecules in different manner, right? So heat flow will also take place differently in liquid medium. So the methods of the heat flow have been basically divided into three. One is the conduction, one is the convection, and another one is the radiation, guys. Any confusion so far?
So I didn't
Yes.
understand the last topic. Like,
Okay, the liquid one.
no, so the solid and yeah, the other
Okay.
thing.
Okay, we are now going to discuss each of them in detail. Okay, then the concept is going to be very clear.
Okay,
Okay.
so
Okay, I've just given a brief overview of the concepts here. Okay, so now look here. This is a classic example in which all three methods, in which all three ways of heat transfer can be observed here. So whenever we are heating water, okay, look, conduction, convection, and radiation. All these three methods, all these three ways of heat transfer can be seen here. So conduction, talking about conduction, let's first discuss about conduction and then we will come back to this figure. Okay, so let's talk about conduction. Right. So look at this figure over here. You have placed a metal strip, okay, via two bricks here, and it is above this candle here. All right. So let's try to understand how heat is flowing from one end of this metal strip, from one end of this metal strip to another end of the metal strip, right? Okay. So now you guys do tell me first fundamental thing that what is it that all solids are made up of? Whether you talk about solids, liquids, or gaseous. What is the
molecules,
fundamental particles? Molecules,
molecules,
right? If we were to if we were to what do you say, that if you take example of molecules, for example nitrogen molecules, it is N2, right? So if you break it further, it will break into two nitrogen atoms, right? So when two nitrogen atoms combine together, then molecules are formed. So the smallest fundamental and structural unit of any substance is atoms. And when two or more atoms will combine together, they will form molecules. Right, guys? Okay. So that is the fundamental
okay, so
thing. I'm guessing you guys are aware of it
Sir,
now.
can you explain again?
Yeah, sure. Let's say that oxygen, which we see in our atmosphere, it exists in molecular form, that is O2. But this O2, if you break it further, it will break into two oxygen atoms, O and O, right? So this O2 here is molecule, which is made up of two atoms, two oxygen atoms, right? So basically when oxygen atoms join together, it led to formation of oxygen molecule, right? Because atoms cannot exist independently. Okay, they will they will have share with another atom. Okay, they won't exist independently. They will have friendship with another atoms and then they will exist in the form of molecules, right? Got this basic thing now?
yes, sir.
Yes.
Okay, good. Now look, if we have a closer look at this metal strip, it is definitely made up of this molecules. It will have a different type of molecules. This metal strip is going to have some molecules, right? Okay.
Yes, sir.
And do tell me one more thing. What happens whenever we heat anything? It starts to
Melt.
Melt.
melt. Okay. But if we were to talk at a molecular level, you will see that the molecules in this metal strip, when they are heated, they will start to vibrate. They will start to vibrate, right? The molecules will start to
Yes,
vibrate
sir.
to and fro. They will start doing to and fro motion. Why? Because they are being heated from one side. They are being heated here. So due to vibration, one one molecule will transfer its energy to another, and then another molecule will transfer to the next series of molecules. So in this way, due to continuous vibration of molecules, the energy, that is basically heat here, it gets transferred from one end to another end. Got it?
Yes, sir.
Right. So we can say that this method of transfer of heat from a hotter part to a colder part of an object due to collision of its particle without actual movement of the particle from their position is called as conduction. Let me repeat it. We know that what is happening here. The molecules are under continuous vibration. They are colliding with each other now. The molecules are colliding with each other, right, guys? So due to that collision,
Sir.
the transfer of heat is taking place here from this hotter region to the colder region. But do tell me, is there actual movement of molecules in this one? Like the molecules at this end, does it get transferred to this end?
No, sir.
No, obviously no. All right. So this is the method which is simply called as conduction. Okay, so how do we define it? Let me write a definition for it. Okay, or see, there's a definition here. It is the transfer of heat from a hotter part to a colder part of an object due to collision of its particle without actual movement of the particles from their position. Okay, right. And
Okay,
heat
sir.
transfer through conduction occurs within solids and between solid substances that are in contact with each other. Okay, so here you were seeing that this flame was in contact with this metal strip, right? Okay, and let's say if you were to bring another metal strip and you were to attach it to this portion. Okay, so when this portion here, when it was hot, when it became hot, now what will happen? There will be transfer of heat from this, let's say it to be metal strip A, then there will be transfer of heat from this metal strip A to metal strip B, right? So
Yes, sir.
few things, let me list down what are the few things which we have discussed so far regarding conduction. So first thing is that it is movement or transfer of heat from where to where, guys?
From hotter part to colder part.
Colder part, good. Okay, of an object, and that object will be solid. Okay, that object will be solid. So how transfer of heat takes place? Due to collision of molecules. Got it?
Yes, sir.
Due to collision of molecules. And do tell me, is there any actual movement of molecules?
No, sir.
No, there isn't any actual movement. Sundus, you are getting these concepts now?
Yes, sir.
Yeah, molecules, molecule particles, right? Okay, and one more condition, as I said, that it occurs between solid. Okay, so transfer of heat can take place from one solid to another, one solid to another, guys, right? Okay, so basically this is how the transfer of heat takes place in solid objects. So we can conclude here that this conduction method is specifically for solid mediums only, right?
Yes, sir.
Okay, now let's have a look at some of the types of objects that conducts the heat. Okay, some of the solid objects, like we have got different types of solid objects, but not all of them are good conductors of heat. Not all of them allows heat to pass through them easily, right? So if you take a piece of rock or if you take a piece of metal, in which case the transfer of heat will be easier, guys?
So what, sir?
My question is that if you take a piece of rock, if you take a piece of rock and you take a piece of metal rod, in which case that flow of heat is going to be easier?
Metal.
Metal rod,
Metal.
obviously, no, right?
Yes, sir.
Because this rock is a non-metal here, and metals, we know that they are good conductors of heat, right? So metal rods are
Yes,
basically
sir.
good conductors of heat, while this rock is a non-metal and it is a bad conductor of
Bad
heat. And
conductor of heat.
right, so it is also called as an insulator, right?
Yes, sir.
Okay, so we have other examples. Give me some other examples of objects which are although solid but they are bad conductor of heat apart from this rock.
Steel.
No, steel is a good
Wood.
conductor.
Wood.
Wood, yeah,
Not it's like bad conductor examples.
yeah, bad conductor of heat. I'm talking about bad conductor. That is insulator. Wood is a
Okay, sir.
bad conductor of heat. Okay, like if you were to heat a piece of wooden plank from on one side. Okay, let's say you are heating it using a candle from one side, but on the another side you won't feel any warmth, right? This side will not feel it, will not have any warmth in it. You won't feel it to be warm. Why? Because it's a bad conductor of heat. Although this part of the wood is getting burned here, but the flow of heat is not good in this one. Getting it, guys?
Yes, sir.
Okay.
Yes.
So when we are talking about insulators, that is a bad conductor or good conductor, we actually talk about those objects. We are actually talking about the rate of flow of heat, like which objects easily allows heat to pass through it, right? Although this wood is going to be going to burn here, it catches fire, but the flow of heat is very slow. Hence, we call it to be a poor conductor or insulator. Some other examples are clay, right? Or let's take example of rubber, right, guys? So these are not bad conductors of heat. And for good conductors of heat, we have got so many examples, right?
Iron.
Iron, yeah.
Steel.
Which
Steel.
one? Steel, good.
Steel.
Copper, right,
Yes,
etc.
sir.
We have so many examples. So basically, we know that rate of conduction of heat is different in different solids. It's different in different solids. Okay, so some of the materials easily allows to pass heat through it, and hence they're called as conductors. So whenever you hear the term conductor, it basically means metals. Immediately you should have idea that we are talking about metals here. Okay, and we already see that examples of materials, like although they are solid but they are bad conductors and also called as insulators, right? Okay, now what
Yes.
about the materials like wool, feather and fur? Why are they considered as insulator?
Because
Yeah,
air is trapped in the small molecules. You explained in
exactly.
the last.
Exactly, in the previous class now we studied about this. So let's say we are taking a closer look at the fibers of a cloth. Okay, so in this fiber, we are having a zoom look here, let's say. So in between them, air molecules, let's take it, this green circles, let's consider it to be air particles trapped in between the fibers. Okay, guys. So air particles are trapped in between them. And we know that air is a bad conductor. It's a bad conductor. That's why the materials like wool, feather, and fur, since they have air trapped in them, that's why it acts as a bad conductor of heat. That's why in winters we normally prefer to wear sweaters made of wool, right?
Sir.
Okay, now take a look at some of other examples like copper, gold, and aluminum, right? These are good conductors. Okay,
So
see this.
silver is also a good conductor of heat.
Yes, Sandoz, please repeat.
So silver is also a good conductor of heat.
Yeah, exactly, silver is
Yes.
also a good conductor, right? Okay, and
Yes.
see other examples like plastic wood. This plastic here, the handle of the utensils, basically It is especially made of bakelite. It's a type of uh, plastic that does not melt easily. Okay, that's why it is used to make handles of the utensils. And this styrofoam. Okay, these are the objects that are considered as insulators, right? Okay, now let's have a look at some of the practical examples of applications of conductions. Okay, so some of the applications of conductions, as you saw in this one here, the handle of this pan is made up of a plastic. Why? Because plastics are bad conductors of heat, right?
Yes,
And in
sir.
fact, plastics are bad conductor of electricity as well, right?
Yes, sir.
Okay. So if we were to make the handles of the handles of the pans of metal, it would burn our hand, right? Okay.
Yes,
Other
sir.
example we just discussed about the clothes, for example, wool that traps air inside them, and since air is a bad conductor, they help us keep our body warm. Okay, right. Okay, now
Yes, sir.
let's discuss some questions. Right. Which of the following is an insulator? Yes,
And eight.
air. It's air. Good.
Yes, sir.
The process by which heat flows from the hotter into colder end of an object is called
Conduction.
Conduction.
conduction. Good. Okay. Stainless, read the question and see which one is the correct answer here.
D1.
Last one.
D,
Copper.
sir. D.
Right.
Copper
Than
is
the
a
stainless.
better conductor of heat than the stainless steel.
Yeah, exactly. That is the reason why the base is made up of copper. Right. Good. Now look at another question.
Summer.
Summer. Very good. Okay. Because usually we see that light colored objects are what? They are insulators, right?
Yes, sir.
They reflect heat, while black or dark colored objects, they are good absorbers of heat. That is the reason we don't consider to wear dark colored clothes in summers. Okay.
Okay.
Okay. And do tell me why during a winters a metal object which is kept in a room feels very cold to touch, but a wooden object in the same room feels warmer to touch.
Metal is like a good thing to absorb the cold. I think so. That's why it's
No,
colder.
no, it's
So,
opposite now.
would you
Metals are
repeat the
good.
question?
Uh, would you like me to repeat the question?
Yes, sir. I didn't understand actually.
Okay, sure. Look, during winters now, winters,
Sir.
whenever you will touch a metal object, you will feel it to be colder as compared to a object made of wood. Why is it so?
Yes.
It is colder to touch, while a metal object made up of wood, it feels comparatively warmer. Comparatively warmer, although it's not warm, but if you were to compare, it will feel warmer. Why is it so, guys? Okay, let's take the first example here. Okay, look, we know that metal objects are good conductors of heat. Now, metals
Yes, sir.
are good conductors. Okay, so if you are touching an object, a metal object, what happens there? We know that heat, the trans as look as compared to the metal object, which is cold, our hand, our body, or is that metal object is more cold? Let's say this is a metal object, okay, and this is our hand. Okay, in comparison to the this metal object, our hand is more warmer now. Okay, and we
Yes.
know that let's, we know it is going to be colder. We know that flow of heat takes place from a warmer region to a colder region, guys. Okay, so when we are touching this colder object, that is a metal here, there's flow of heat taking place from our hand to this cold metal. So we are losing heat now. So by losing the heat, our hand feels cold. Okay, while on the other side, the wooden object, since it's a poor conductor, this is a poor conductor here, and we know that it does not allows heat to pass through it easily, right? So that is the region it does not allow the heat of our hand to escape, and hence it feels warmer to touch. So take a wooden piece, let's take a wooden object here. Okay, and this is our hand. So if we were to touch that wooden object, our hand won't feel colder. Why is it so? Because it's a poor conductor, it's an insulator that does not allow heat to pass across its particles. That is the reason why why our hand will feel warmer while touching this wooden object. Got this? Not specifically warmer, but but we won't be feeling colder also. Okay, got this thing now? Okay, shall we move ahead then? Okay, see this question.
Solid.
Solid,
Okay.
sir.
Solids.
Solid.
Good. Okay, now let's look at another mode of transfer of heat, that is convection. That is convection here. So what is convection? It is also the transfer of heat from hotter region to colder region, right? But it is specifically observed in liquid and gas, right? And there is actual movement of particles of liquid or gas in this method. While in the conduction, we were saying that there was no actual movement of the particles of the object. By collision between them, the flow of the transfer of heat was taking place. Why collision now? Right.
Yes,
So
sir.
let's see in convection what happens. We are boiling some water here. Okay. Now look here what happens. When we are heating the water in this utensil here, what happens? The cool molecules, you know that anything that is hot, obviously it is going to rise up. Hotter particles, okay, are lighter and rises up. Hotter particles are lighter, lighter in weight, and they tend to rise up. And cold molecules, cold particles are heavier. Particles are heavier and they tend to fall down because they are heavier. So you see here the cool molecules are falling to the bottom of this beaker here, of this utensil here, and the molecules, when they reach the base of this utensil here, they get warm, they are heated, and then they become hotter particles, and since their weight is now lighter, they are going to rise up. Getting it, guys?
Yes, sir.
So there's a continuous cycle of motion of cool molecules and warm molecules. So there's an actual movement of molecules in this one now, right?
Yes, sir.
Okay.
Then after this all, the
Yeah.
process, the bubbles come and show up at the surface.
Yeah.
Right?
Yeah. So when all the regions of this water are equally warmed, they have reached the same temperature. Okay. So in case of water, that is said to be as 100 degrees Celsius, that is also its boiling temperature, right? So that is the maximum temperature that these cool molecules, these water molecules can tolerate. After that, they will start to change their state from liquid to gaseous state, right? So when they
Yes,
receive
sir.
their maximum temperature holding capacity, that is 100 degrees Celsius. The state
100.
from liquid to the state is changed from liquid to gaseous state, right? That's why they start to evaporate here and vibrate. The particles start to form bubbles, right, guys?
Yes,
Okay.
sir.
So few
Transfer.
important takes from this discussion, that it is the type of flow in which there is transfer of heat from hotter part to colder part of liquid and gaseous medium. Okay. Another important thing is about this type of mode of transfer of heat is that there is actual transfer of particles. Can you guys tell me why there is actual motion of particles of the medium possible in liquid and gas, and why not in solid?
Sir, can you repeat the
What,
question?
sir?
Yeah, my question is that why there is actual movement of particles possible in case of liquid and gas and not in the case of solid,
So
like in
because in
solid.
solid
Yeah.
molecules it is tightly packed and liquid it is loosely packed.
Yes, exactly. Okay, they are tightly packed and fixed at a place and cannot move about freely, right? Okay,
Yes, sir.
all right. But then what about the vacuum or the empty space? Why in a vacuum heat transfer cannot take place?
In
Huh?
what?
In
In
vacuum,
what?
why in vacuum I have written here, why heat flow is not possible in vacuum? Yeah,
The water
because
is not.
my question is now, why heat flow is not possible in vacuum where there's no particles, empty space? The answer lies in
Because air is air is there.
no, air is not there. No, in vacuum there is no air, it's simply empty, nothing in it, because the basic reason is there is no particles in vacuum. No, no particles in vacuum, right, guys? And we know that for transfer of heat, whether it is by conduction or whether it is by convection, and later on when we will talk about radiation, uh, especially in case of conduction and convection, you will see that heat transfer is not possible via conduction and convection. Heat flow is not possible in vacuum. Take this statement carefully here, via conduction and convection. So the question is that the sun is lakhs of kilometer away from the earth, right? So and
Yes, sir.
outside the ionosphere, that is the outermost layer of the atmosphere of the earth, that is the ionosphere. Okay, there is empty space and there is vacuum. So how does heat flow takes place in that one? Since it's a vacuum, it does not consist of particles. So remember just one thing, that heat flow via heat flow in vacuum is not possible via conduction and convection. But the another mode of transfer of heat that we will talking about later in next class, that is radiation. So it is
Radiation.
due to radiation. Yeah, it is due to radiation how heat transfer from sun to the atmosphere of the earth or to earth. Got it, guys? Okay,
Yes,
so
sir.
that we will keep for next class. Today we will be only talking about convection. Okay, Sundus and Vaika.
Okay, sir. Oh,
Okay, now let's talk about convection in different mediums. Different mediums, basically liquid and gases. So we know it can take place in liquid and gases. Okay, so how convection takes place, you guys are already aware now. No need to discuss that one again. Okay.
okay, sir.
Okay, remember the last point here. The process of movement of the particles continues and gives rise to a convection current. So one more thing here, that this circular motion of the particles, this generates a type of current called as convection current. That is very important here. Convection current. So cool molecules are falling to the base of this utensil, and hotter molecules are rising up. So there is a kind of continuous motion, circular type of motion, that is called as convection current. Getting it?
Yes, sir.
So this gives rise to a convection current through which heat energy flows and the entire liquid or gas gets heated. So it is due to this convection current, the entire medium, whether it's liquid or gaseous, all the medium gets heated, and eventually all the particles, all the molecules will have same temperature. Until
Okay,
that,
sir.
it will continue. Okay, so before we talk about these land breeze and sea breeze, I'm guessing you guys are already aware of it. Let's discuss
Yes,
about
sir.
how convection takes place in water and how in air. Okay, so considering the example of water which we were just discussing about it, convection in water. Okay, so do tell me, is water a poor conductor or good conductor of heat?
Bad
Water,
conductor.
bad conductor. Okay, very good. Note this thing, that water
Is a
being,
bad conductor.
yeah, it's a bad conductor, it's a poor conductor. Water being a poor conductor of heat cannot transfer cannot transfer heat via conduction, right? That's why it conducts the heat via the method of convection. Okay, and talking about air, is air a good conductor or bad conductor, guys?
It's a bad conductor.
That is also a bad conductor. Okay, so in case of air, in case of air also, convection current is generated, and due to that convection current, the heat transfer from hotter part to the colder part. Okay, now let's come to the concept of how there is a flow of heat taking place in coastal regions. You guys know what is coastal regions now? The region where seas and land meets, that is called as coastal region, right? Okay, so in daytime, what do we observe? That there is a flow of wind or breeze generally from sea towards the land now. Have you guys been to coastal region? Hmm? Have you guys visited any coastal regions? So if not, if whenever you
Yes,
will
sir.
visit a
Yes, sir.
coast, okay, good. Okay, since you are Kerala, you must have visited. Okay,
Yes, sir.
okay, so you must have observed that there is flow of wind during the daytime from the side of sea towards the land now, and during the night, there is opposite movement of wind that is taking place, that is from land towards the sea. So why this type of movement of wind takes place, that we are going to discuss here. So keep one basic fundamental thing here, that land heats up faster than water. Okay, land heats up more than water or faster than water. Let's say, to be more precisely, heats up more than water.
So the land particles heat up the water particles.
No, 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 that is not the case. Land heats up more than water. Okay. So now let's talk about what happens during daytime. Why there is flow of wind from, what do you say, from seaside to the land side. So look, the reason lies in this statement that land heats up more than water. So if the land heats up more than water, let's see the molecules above the land. they are going to be heated more now. Let's say
Yes,
that
sir.
this is your land and this is your water region or sea over here. Okay. Now, since land heats up more than water, okay, and water heats comparatively slower than the land, what will happen? The air molecules above this land are going to heat up more and they are going to become lighter now. Remember, earlier we talked about this thing here, that how
Yes.
hot molecules of water rises up and cold molecules comes back to the bottom of this utensil. So in the same manner, the air on the land side are comparatively warmer than the air molecules on the water side, right guys? So these air molecules will start to rise up. They will start to rise up now. So there will be a gap now. There will be a vacuum being created here since the
Yes,
air
sir.
molecules are rising up. So that gap is being occupied these by these colder molecules of air that will take place. The that will take the place of this emptiness here. Getting it, guys?
Yes,
So
sir.
these molecules will occupy this empty space here. So that's why there is movement of winds from the seaside to the land side, and that is being called as what? That is simply being called as sea breeze, or sorry, land breeze. Right? Got this thing now? So basically during daytime,
Yes,
since the
sir.
land is warmer, there is flow of air molecules from the sea side to the land side. Okay, and this generates a convection current that is called as sea breeze. Okay, sea breeze, not land breeze. All right. And opposite happens in the night time. So what will happen? Take one more important note here.
Sir,
Note
in
two.
night, the cool air from the land moves
Yeah,
towards the sea, right?
exactly. One more note here. Land loses heat faster than water. Faster than water. So water is also being heated and land is also being heated during the daytime. But what happens as soon as it's night time, land will lose the heat faster than water. So the air molecules above the land, now let's understand via another diagram. So the air molecules during the night time above the land are comparatively colder now. The air molecules are comparatively colder because the land loses heat faster, and the water loses heat slower than water, while land loses heat faster. Loses heat faster, sorry, faster. Getting it, Sundus and Vaiga?
Yes, sir.
Okay, now have a
Yes.
look at the water molecules on the seaside. So the water molecules, since they are more warmer, they will start to rise. They will start to rise, and there will be an empty space created here, and that empty space will be taken up by the air molecules from the land.